Due to arid condition, saline and sodic soil are usually found in our soil. Chemistry of saline and sodic soil. Actually, we have three types of salt-affected soil. These types are saline soil, salt problem in general, sodic soil, sodium problem, saline sodic soil, problem with sodium and other salt, high salt and high sodium concentration. Salt-affected soil are often found in arid and semi-arid areas. In wet area, salt-affected soil does not consider a problem because the amount of rainfall is sufficient to remove excess salinity from the soil. So rarely found saline soil in wet area. Some salt-affected soil may be found along the shores of the seas where the sea water reaches this soil. Causes of soil salinity. The first is soluble salt under arid and semi-arid climate where there is insufficient water to leach soluble salt from the soil. Salt accumulate due to evaporation is dominate in the condition where the precipitation is very limited. The dominant cation found in saline soil and water are sodium, calcium, magnesium, potassium, while the anion are chloride, sulfate, hydrogen carbonate, carbonate, and nitrate in some time. Bicarbonate ion is present in a result of interaction of carbon dioxide with water. The source of carbon dioxide gas is either air or as a result of respiration of plant root and microbes react with water to produce hydrogen carbonate. The carbon hydrogen usually raise the pH to 8.5 or higher. So the first is the first cause of soil salinity is soluble salt, either applied to the present in soil in arid and semi-arid condition. The second reason is evaporation. In arid and semi-arid, evaporation is higher than precipitation. Consequently, water lost by evaporation is between 50 to 90% of the soluble salt. Increase from 2 to 20 times. So in arid and semi-arid environment, evaporation is very high, whereas the precipitation is very low. This led to increasing concentration of salt in the soil. The water evaporates while the salt accumulates on the surface of the soil. The third factor is drainage. The poor drainage can cause salinization of soil due to the increase of groundwater level. Saline groundwater, usually groundwater have a high salt content. And the water, the poor drainage water cause salinization due to approaching the groundwater to the surface, and the water and the capillary action carried out, especially if there is the groundwater on a clay soil. The capillary action is conducted. The water reaches the surface. The water evaporates while the salt accumulates on the surface or on the top of the soil profile. The fourth important cause of soil salinity is the application of saline irrigation water, or the using of saline water for irrigation. The high concentration of soluble salt in water, such as sodium, boron, and other elements, has adverse effect on soil properties and plant growth. Of course, if you apply bad water, then you will deteriorate your soil, and consequently, if you add saline water in irrigation, consequently, the salt will be accumulated in the soil, and the soil will be deteriorated. However, especially in arid condition, where the evaporation is very high and the salt accumulates on the surface. However, if you are using fresh water, the accumulation of salt will be low, while leaching process will be dominate. So we have four factors causing soil salinity. First one is soluble salt on the soil, which is not be removed from the soil profile and accumulated time by time, especially in arid and semi-arid condition. Evaporation is high in arid and cause accumulation of salt. Lack of drainage system, efficient drainage system will lead to salinization of soil. The first most important factor is irrigation water quality, or irrigate the soil with saline irrigation water. How we express salinity expression? We have an expression called total dissolved solids, or TDS. It represents the sum of soluble cations or anions in the soil in milligram per liter, or milli equivalent per liter. It's a unit of expression of the salt. Milligram per liter. Liter of water extracted from the soil. To determine the salt on the soil, you have to first dissolve the salt in distilled water and extract this water, and if you evaporate this water, you will gain the soluble salt. You will obtain the soluble salt. So on the soil. So how we measure in all method for determining total dissolved solid, that you put fresh water, distilled water to the soil, and mix, and then extract the water. The water will dissolve all soluble salt. If you evaporate the water, the salt will be a precipitate. If you weigh this soil, you will obtain the concentration of the salt on the soil by milligram per liter, or milli equivalent per liter. The total dissolved solid, the dominant salt, the dominant ions on soil and water is calcium, magnesium, sodium, potassium. TDS equal these cations or those anions, carbonate, hydrogen carbonate, chloride, sulfate. So TDS equal the summation of cation, these cation, or summation summation of anion in milli equivalent per liter, or milligram per liter. Actually, the fast method for measuring, and all of scientists are using now this method, or agriculture engineer now use this method for determining the soil salinity. This method by using electrical conductivity method. The EC is used as a guide to soil salinity, and you can convert the soil salinity to TDS by multiplying the soil salinity on a constant factor, because there is a direct relation between electrical conductivity of the soil solution and its TDS. The higher the electrical conductivity, the higher TDS. TDS, it has the unit is the soil salinity has the unit of DC Siemens per meter or millimoles per centimeter. Then here is the unit of electrical conductivity as a unit of DC Siemens per meter or millimoles per centimeter. The same. DC Siemens per meter equal millimoles per centimeter. The EC has the unit of DC Siemens per meter or millimoles per centimeter, and both units are same. This is old unit, and however this is a recent latest made unit. So if you have the EC, by using EC meter, it's an apparatus, have two electrodes, and both this electrode on the source of electric, and you can measure the electrical conductivity easily and convert the electrical conductivity to TDS by multiplying on 10. If you obtain the electrical conductivity and multiply on 10, you will obtain TDS milli equivalent per liter. However, if you multiply in 640, if the EC is less than 5 DC Siemens per meter, you will obtain the TDS in milligram per liter. This method is based on the fact that the current in the salt solution increases with the increase of salinity of solution due to the increase of concentration of dissolved ion under standard condition. The electrical conductivity of irrigation water range between 0.15, this is fresh water or rainy water, and 50 DC Siemens per meter. 50 is sea water. The electrical conductivity of the soil solution and drainage water will be higher than the irrigation water due to evaporation and accumulation of the salt. Irrigation water is a good and suitable for use in irrigation without causing any problem if the value of the EC is less than 0.7 DC Siemens per meter. If the EC more than 3 DC Siemens per meter for irrigation water can be affect the growth, and the productivity may the crop productivity may be affected.